Welcome to the webinar, Removing Problematic Fluoride in Drinking Water from Residential Water Wells. I'm Cliff Tryons, Director of General Public Outreach for the National Groundwater Association. It is my privilege to introduce our presenter, Roger Miller of Water Systems Engineering in Ottawa, Kansas. Mr. Miller has more than 35 years of experience in multiple areas of the water industry. His work has involved research and development, project oversight, and technical training for managers of water systems. During the presentation, feel free to type questions in the question box. At the conclusion of Mr. Miller's presentation, he will answer your questions. Also at the conclusion of the presentation, we will make a handout of Mr. Miller's presentation available for downloading. So without further delay, I'll turn it over to you, Roger.
Thank you, Cliff, and welcome everybody today to talk a little bit about fluoride in drinking water, specifically targeted towards our residential wells. And I want to go through a series today, really kind of say what is fluoride, where does it actually come from in our groundwater systems, what kind of problems or benefits does it present to us, and then what can we do about the problems that it may generate. So looking at fluoride, it's a naturally occurring mineral, actually, in our subsurface, in our geological formation. As our groundwater systems or our aquifers flow through the subsurface, there is a dissolving activity that goes on, and it actually breaks down or degrades a little bit of that rock formation. Basically, fluoride, eptite, and cryolite are the three general minerals that we get fluoride from in our water system. And a small amount of those constituent chemistries end up in the water source. Ironically, for fluoride, it is known that when the water is what we call alkaline or a little higher in its pH value, that the water has a higher tendency to solubilize fluoride out of the minerals that might be present in the geological formation. Ironically, I say, because in most situations, it would be more of an acidic water or a lower pH water that would normally dissolve minerals out and provide that mineral in our water supply, where fluoride's a little different. Alkaline water, a little higher pH water, is actually produced a little easier in those types of water chemistries. When we think about fluoride in our daily lives, and certainly in our body functions, most humans and animals use fluoride in the structure of their bones and teeth. When we talk about teeth, we're normally referring to the enamel formation on our teeth, the protective surface of our teeth. And I think as the dental profession came through years ago, the presence of fluoride in our body has a tendency to reduce the formation of bacterially induced cavities in children specifically. So a little bit of a benefit is certainly the avoidance of bacterially based cavities in our teeth, and some other structures may be non-beneficial to us. And when we look at that, we're talking about when fluoride in our life, not only provided by our water source or our drinking water supply source, but in other areas of our life, provide excess or excessive ingestions of fluoride, we can have issues which were called fluorosis. And fluorosis is a effect on our teeth predominantly, and as you can see here, it's a discoloration of the surface and irregularities. When we look at fluorosis, or in some, you might have heard a term referred to as molted teeth, which is very characteristic of the picture on the right. A very minor fluorosis would be maybe some spots on the teeth which look like a very white paper look to them. More of a moderate fluorosis would be kind of a white opaque spots on your teeth. And then what we would call extreme or a severe case of fluorosis is this brown staining of the teeth and eventually actually teeth destruction. When we think about fluorosis or fluoride in our water and either the benefits or the problems caused by it, we do have stipulated by the US EPA some what we call primary drinking water standards. And under those standards, we have certain parameters that we consider a maximum contaminant level, or an MCL, you might hear us refer to in the water industry. And for fluoride, the maximum contaminant level for municipal water districts on fluoride is 4 milligrams per liter, or what we might refer to as parts per million. Those primary drinking water regulations for municipal water districts are requirements. They have reporting protocol if they exceed those limitations. They have activity protocols if they exceed those limitations. So a guideline for effective water use and avoiding or controlling the concentration of fluoride is set at a maximum contaminant level of 4 milligrams per liter. Throughout the world, as we see people who actually drink water with fluoride in excess of that 4 milligrams per liter over many years, and the bone issues associated with fluoride do have a long time of effect. But as this photograph shows, in India, of course, they have very high fluorides in their water, and fluoride deep wells, fluoride-laden deep wells over there, and over half of their groundwater in that country have excessive concentrations of fluoride. So they do experience the effects of bone disease and bone deformations caused by the ingestion of too much fluoride over their life period or for a long period of time. When we look at our well systems, of course, we do have in our regulatory standards, we do have what we call secondary drinking water regulations. And these are non-enforceable regulations that are more guidelines or recommendations as far as what the regulators, the EPA, feels that we should utilize in even our groundwater systems and residential well systems. So we're looking at in that secondary standard a maximum contaminant level of 2 milligrams per liter, or parts per million, and that predominantly is a great guide for the dental fluorosis and I guess over time certainly for bone deformation that we saw in some of the other countries across the world. Specifically, children, the age of 9 or below, should be guided in their ingestion or utilization of fluoride, because the biggest effect on our teeth is during that growth area up to about 9 years old, where our enamel on our teeth is predominantly the structure that's going to eventually affect our teeth over a long period of time. So we have some guidelines that are even stipulated up to about 9 years of age, that these guidelines should be utilized, because that is the time when our teeth are forming the enamel that eventually will be the protective coating that it'll have throughout our life. I think this is a great map that we have based on a 2006 report on groundwater systems. Where is our natural fluoride in the United States? Well, as you can see, in parts of Texas and Colorado and the Dakotas, we have elevated concentrations of fluoride that are greater than 0.5 or half a part per million, or milligrams per liter. They're naturally occurring in our aquifers throughout those areas. In this national sampling, U.S. Geological Survey found that about 85% of the residential wells tested in the United States were well below the U.S. EPA maximum contaminant level of 4 milligrams per liter, or parts per million. So as you can see on the map, the very light blue areas are actually less than 0.7 milligrams per liter, up to the very dark blue areas are somewhere above or greater than 2 milligrams per liter. So really looking at the United States, we only have some areas, I guess, isolated areas where we would have potential groundwater that might be a problematic area and certainly should be evaluated. But I think anytime we need to at least gauge those concentrations for knowledge that our groundwater system is not above those regulations. So when we look at what do we do about fluoride, I guess the first thing is certainly finding out what our source supply situation is. And the first thing would be testing of your groundwater system to see where the fluoride concentration is. And I think our recommendation, and certainly my recommendation, would be to utilize a certified drinking water testing laboratory and certified professionals in the industry to make those tests and make sure that they're accurate and that the results are the right results. Because what we're going to be talking about is what do we do about potentially high levels of fluoride as far as treatment technologies or maybe even well construction technologies. So a lot of people ask me, is there a field test? Is there a dropper test? Is there some type of test? Well, certainly there are, but the recommendations when we're dealing in water quality, especially controlled and regulated water quality, is to utilize a certified drinking water testing laboratory. Generally, your county health department can help find the proper testing, and a lot of state organizations. In fact, a lot of states even have their own testing laboratories for water quality. Or certainly you can obtain a list within your state from our website, www.wellowners.org, and looking at water testing. So there's a variety of ways to find certified testing laboratories. The test for fluoride is not an expensive test. A lot of state laboratories, state-run and certified laboratories are very well positioned to make that test for you, and generally those costs are fairly affordable. So once we've kind of found out that we might need to do something about fluoride, we have a few options, I guess you could say. And when we look at what can we do from the well standpoint, if our well is already drilled and constructed and we're using it, there are a few options. Your qualified well professional can look and inspect your well and make some recommendations on construction changes. If the fluoride is being produced from a specific flow zone out of your well, and this doesn't occur all of the time, but certainly is a possibility that the high fluoride may be coming from a certain area or zone in the producing area of your well. And of course, if that's the case, then we can actually block off that producing area and either lower or eliminate the high fluoride concentration in your drinking water flow. That consists of basically either packering off that area or placing in a swedging in a blank, closing off that particular screened area of the well. Certainly, number two, anytime that we're looking at drilling a new well, we want to do a evaluation or at least utilize, or our well contractor will utilize historical data on the aquifer, and they'll be able to decide or determine if that particular aquifer area might have fluoride issues, and if the potential exists to design the well around those areas where we don't put a screen zone into that particular area of the aquifer. So, and those are, like I say, those are issues that don't occur every time we're looking at a well or repairing or changing a well, but certainly are an option to remedy the high fluoride concentration that's coming into our residential water wells. The other aspect, of course, for reducing fluoride is water treatment. And water treatment in today's world is becoming certainly more prominent, more affordable, higher technologies involved in the ability to remove certain, I'm going to call them contaminants, out of our water. And when we look at fluoride, we're predominantly looking at three major categories, I guess you'd say: reverse osmosis technology, ion exchange technology, and probably not so much in drinking water, but certainly in high-grade water would be the distillation process. When we look at reverse osmosis, it's kind of a unique process. When we think about how we actually remove contaminants or even particulates from our water with reverse osmosis, when you look at osmosis, that's the natural movement of a solute or water through a semi-permeable or permeable membrane, and of course all the bad stuff stays on one side and all the clean water goes through the membrane and on the other side. When we looked at the technology of reverse osmosis, we actually have applied a pressure to that process rather than just letting the pressure differentials be selected by the natural occurrence. So we're actually kind of forcing that water through the membrane and allowing the membrane to do that filtration. And the filtration actually occurs all the way down to the ion level or the submolecular level. So we're really removing quite a bit of material, almost all of the material out of the water through the RO process. So RO units are a very high-grade type of water treatment. There's membranes as far as in today's water treatment world. We actually have RO at the very top of the membrane technologies. We have ultrafiltration technologies and microfiltration technologies, and those are all gauged on the particle size or the ion size that they'll remove. So the quality of the water that they'll clean up is that grade, but the technology of membrane filtration is what we're really referring to. I'd say typically the RO units or the reverse osmosis units are used at what we call point of use, which is generally at the sinks, either the kitchen sink or sometimes in the bathroom sink, but certainly at that point of use, because there's not a requirement for filtering the whole house water generally, and so the reverse osmosis units that we see in our industry today would fit into that category, that we can actually install them at the point of use. The second process that we use in removal specifically of fluoride would be ion exchange. Ion exchange is a little bit different in its process because rather than specifically filtering out either through a membrane or even in sand and gravel type filtration, ion exchange is a media bed. So you have a lot of little balls of media in a vessel, but they have charges on them, either positive or negative charges. And as the water flows through this media bed, there's an exchange of an ion off of the media and a fluoride ion onto the media, removing the fluoride from the flowing water. So we call that ion exchange. Ion exchange is fairly common. Most people have heard of water softeners. That's typical ion exchange technology. Basically, in water softeners, you're removing water hardness, where in this process, we're talking about removing fluoride. But the same technology, very much the same equipment, is utilized in ion exchange for removing the fluoride out of our water. Most ion exchange units, as you can see in the picture here, are what we call point of entry treatment, or they're actually treating the whole water supply to the residential home. So we generally see this kind of an installation for ion exchange. We have distillation as a treatment scheme for removal of fluorides. Evaporation or distillation is actually the evaporation of pure water, leaving virtually everything back in the vessel. So when that vapor condenses back on the other side into pure product water, it generally, unless you get a little carryover, you're talking about pure H2O into that vessel. We don't really see that in the drinking water industry as much as industry and laboratory quality type water, but certainly distillation is a methodology for removing fluoride and producing a very, very clean, pure water. So when we talk about water treatment equipment and products, as far as either RO, reverse osmosis, or ion exchange, We're talking about the industry standards of utilizing certified treatment products. We're talking about using certified treatment technicians. In our industry, of course, we have independent product testing laboratories and companies that verify that not only do these products work, but they meet their technical guidelines that are quoted in their literature. And many of these certifying testing laboratories actually inspect the manufacturing facilities and audit the material flow, so any products being utilized in the construction or manufacturing of these water treatment technologies meet certain standards. So I guess it's an excellent assurance that the products that we're using in our home for removing of fluoride meet all the specifications that they were established for, and they work. They do the good job. National Sanitation Foundation, NSF, you'll see this label on most of those products. Throughout the industry, we use NSF certified chemicals and equipment and devices. So NSF is one of the premier certifying organizations within the water industry, along with the Water Quality Association, which also has a equipment certification protocol. So the recommendations are certainly from National Groundwater Association would be the utilization of certified, inspected, and verified products, along with the installation technology contractors. So when we think about utilizing the right people in the industry, we can look at the organizations of the Water Quality Association, certainly an excellent group, and a lot of good information on their website, the www.wqa.org. And again, the National Sanitation Foundation at nsf.org all can provide us information on water treatment products. There's even some recommendation standards on their websites. And of course, the professional certifications from the standpoint of the professional water treatment people, the installation and certification of their products all through these websites. So we encourage you to visit the wellowner.org website, find out more about useful well owner tools like a hotline, private well owner tip sheets, certainly more on well owner lessons and free webinars. Learn more about your wells and the problems and issues that we can help guide you. Don't forget about wellowner.org for online lessons. Like what should I test my water for? How should I maintain my well? How can I help keep my water safe? What should I do if my well floods, which in today's world here in the United States is a hot topic? How do I get water treatment? And what should I know about getting a new well, as far as even drilling a new well or replacing an old well? So I wanted to tell you, please join us next week for another webinar. This is I guess in the last couple of weeks, this will be the third in a series. It's water treatment systems maintenance, the basics of it. You can find it at this website where you can register for that webinar. Again, good information on the variety of water treatment systems, not only how they operate, but the basics of maintaining and having them maintained throughout their lifetime. So we encourage you to ask any questions that you might have on today's webinar as far as fluoride in our water. You can click on questions on the portal here and go to questions and write your question and send it, and Cliff and I will work through those and we'll try to give you answers. So with that, I turn it back over to Cliff to see what kind of questions we might have coming forward.
All right, thanks, Roger. We do have some questions, so I'll just go ahead and start down the list. First question, I'm confused. You said that we should be concerned about the risk of children under the age of 9 getting too much fluoride, but later you said that people who drink too much fluoride over a long period of time should be concerned. What am I missing? So I guess they're trying to distinguish.
Yeah, let me clarify that. In the formation or I guess you'd say the disc formation of the enamel on your teeth, we're most concerned about those early years, that through age 9. And we're concerned that if the young people ingest too much fluoride in their lifestyle through all their sources where fluoride comes from, then that can affect the formation of that dental enamel. But once they get past those formative years, the dental enamel really isn't so much of an issue with fluoride concentrations in the body. But don't forget that we talked about the bone deterioration and bone diseases, which like we see occurring in some of the third world countries. So if you ingested or took in too much fluoride over a long period of time, we're talking about multiple years here, then the potential for long-term bone deterioration and bone disease would occur. So kind of a two-step issue there. Teeth are really only affected in those formative years where bone deterioration can be even in adults and later on in life. So hope that clarifies that.
Thanks. Coincidentally, I was wondering myself yesterday if the bone disease risk was primarily a thing overseas, and I received an email from someone in the U.S. who happens to live in one of those areas of dark purple on the map where the highest concentrations tend to be found, who said that in fact they do have people in that area who have sustained bone disease as a result of the high fluoride levels. So while it may be isolated, it does exist in this country. Which leads into our next question. The question is, if I don't live in one of those areas in dark purple on the map, does that mean I don't have to worry too much about fluoride in my well water?
Well, I think definitely that's the way we would lean when we look at that map and we realize that the fluoride level in our geographical area may be considerably low. But it's historically in groundwater systems that those maps certainly refer to the average. And actually, when you look at water quality over time from aquifer sources, there can be changes in aquifer conditions. It's not prominent and they're not immediate, but over time aquifer water quality can change due to various changes in, like I say, the alkalinity or pH of the water and their effects on the geological formation that may predicate some elevation of certain constituents, and the water fluoride being one of them. So I think it would only be a good recommendation that even though you live in one of those areas of low fluoride concentrations from that map or any research data that's been performed so far to date, but it would only be good practice to periodically have your well water tested for fluoride concentrations just to make sure that there haven't been aquifer quality changes in your aquifer water and that you're still in those low concentrations of fluoride in your area. So.
Thanks. I would add to that we always recommend that well owners check with their county health department or local health department about anything that might be known to be problematic in an area, because if fluoride is an issue, they may well know about it. The other thing is often like that map depicts places where water was tested, mostly in principal aquifers, but sometimes aquifers are layered, and so a well that isn't in that principal aquifer but in the same area could be drawing from a different source water. So I think that going to the county, if there's problems, they may be aware of them. Thanks for letting me add on to that.
Right.
Next question. Should I test my water for fluoride even if I don't live in one of the areas on the map with higher levels of fluoride? So that's kind of related to what we just talked about.
Yeah, I think my answer would be the same there. That you know, I encourage everybody to at least periodically take a look at that. And like I say, that test is not unaffordable in many states. So yeah.
Okay, thanks. Um, Next question, is it more expensive to retrofit or deepen my well than to get water treatment? Is there a reason other than cost why I should not just get water treatment?
I think basically the first answer to that question is the expense of retrofitting versus water treatment is almost site specific. You know, what would be required from the reconstruction process on the well, and how would that compare with water treatment cost and maintenance and operation, because with water treatment there are ongoing maintenance and operation costs. And I really would refer that to the professionals in your area from the well contractor standpoint on retrofitting a well that's already in existence and pumping water, and have those costs provided by them, and then a professional water treatment person who can say, okay, the best technology for the level of fluoride you may have would be, you know, X, and the overall capital equipment and maintenance and operation cost over the expected lifetime of that equipment would be Y. So you can make a good, you know, I guess you'd say a good evaluation. My thought is, when we look at the ability to modify the well and hopefully eliminate the fluoride coming into the well, that's a permanent fix generally. Those things would be something that you would probably never have to fix again. Where, like I say, water treatment does have operation and maintenance costs associated with it. So, but how that works out from the mathematical comparative standpoint really should come from the professionals in those areas. So, refer that that way.
Okay, thanks. I have a question about labs. Are all drinking water testing labs certified?
No, they're not. They're, you know, there's a variety of labs that are capable of running and certainly can run a very accurate analysis on fluoride. They're not certified as a drinking water testing laboratory. We have a variety of labs that are environmental laboratories. They are testing for a lot of different contaminants in groundwater and in the subsurface for environmental cleanup programs. They use the standard methods that we have for testing for fluoride, just as a certified laboratory would have. So the testing protocol and the results are all going to be the same, but to become a certified testing laboratory for drinking water standards within any state is a process of having your laboratory audited and meeting certain standards. And so those people predominantly go towards the drinking water end of the business, where there's a variety of other labs that are not really certified, but certainly can run the test the same way and produce the same data. So I guess in that instance, if you're looking for, you know, the best recommendation would be to go to a certified laboratory, but no, not all laboratories that you would encounter would be certified in drinking water technology. So.
Okay, thank you. Next question. I thought distilled water was not good for drinking.
Yeah, distilled water, like I say, a lot of times we think of distilled water, at least in my world, in the chemistry world, as a laboratory grade water that we're using for dilution factors that don't impact the water chemistry of what we're testing for. Really, when you look at distilled water, like I say, you're creating a vapor, you're creating steam that's actually coming through the apparatus, the distillation apparatus, and condensing over on the other side is virtually pure H2O. So what we've done and what we realized years ago in the drinking water industry, there was distilled water and even some very high-level reverse osmosis units removed so much of the material from the water, we had no minerals left in the water. So when bottled water first started falling under regulations, a lot of times we required the remineralization as far as calcium and magnesium and some of the minerals that our body needs, because we remove too much from that to be a good drinking water source and provide minerals. A lot of people get their minerals that are required for their body functions from their drinking water. So absolutely there's I guess a question as to how much material do we want to remove from our water when we use it as drinking water. So distilled water, I agree with that, is really probably not a good supply source for drinking water, just from that standpoint. So.
Okay, thank you. Next question. How would I decide which type of water treatment to get? So you've outlined 3 different technologies. What guidance could you give as to which one a person, or how would you decide?
I think number one, of course, would again go to the water treatment professionals. But from my standpoint, when we're looking at the concentration levels, the concentration levels of high fluorides, just because of how the process works, there may be some issues with, say, reverse osmosis technology in removing high levels of fluorides. And that only is from the standpoint of how often you would have to clean the membrane in the reverse osmosis process. So it would be more of an operational issue based on the higher concentrations of fluoride. And even to the magnitude of the ion exchange technology, there would be some limits to the effective maintenance and operation processes associated. So it really would be the guide to that selection process would be, well, number one, what water usage would you have? And if you're going to go with a point of use technology like at the sink, then that usage would be very low. But it would also be based on the concentration of fluoride in the water that you're needing to remove. So that would really be the guide. I don't know that, you know, based on whatever water quality that your well was producing, that would be kind of how you'd make that selection. So without knowing those, I really couldn't tell you, but that's kind of how that guide would be based on water usage and fluoride concentration.
Okay, thank you. Next question. I've heard that reverse osmosis uses a lot of water. Can you explain that?
Absolutely. The process of reverse osmosis is a process that requires a certain pressure and a certain volume of water to flow through the membrane for economics. And in a household application, a residential type reverse osmosis system, that pressure capability, how much pressure we can apply to the water going through the membrane, is fairly low. So we really don't get an efficient and an effective, I'm going to call it filtration through the membrane in low pressure applications. And of course, it's just like anything that you're cleaning and you're removing particulate and contaminants from your water. You need water to flush that material out or off of the membrane and down the drain. So you have not only the inefficiency of not being able to push enough pressure on the membrane to get an effective cleaning technology and save most of the water, and you also have a certain amount of water that's used in the what we call discharge or backwashing process in the membrane. Unfortunately, for household water, especially there at the tap, we're talking about a process that's maybe only 15 to 20% efficient. So you know, you're actually discharging 4 to 5 times as much water as you're actually cleaning up and using. Now, in a water usage at the tap in a household, you're talking about very little water usage, so it's not like you would see a big economical change there. But unfortunately, the efficiency of those units from the aspect of water usage, not how well it actually removes the fluoride from your water, is somewhat inefficient. When I had a very similar question like this come up at a presentation I gave a couple of years ago, and they said, well, what about municipal systems? Well, fortunately, as you process millions of gallons a day or hundreds of thousands of gallons a day in a municipal water treatment plant, the economics of making different applications to that process to clean up that discharge water and more efficiently process water through the membrane are in place for those larger processes. But in a small, low usage, RO system, at the tap generally, yes, I would have to agree that it does use quite a bit of water in comparison to how much water you produce as good clean water. But it is the overall picture is fairly low from that standpoint. So.
All right. If anybody has a question, now's the time to get it in. I do have one more question, and I also want to point out that if you haven't noticed it already, there's a place there in your little panel where you can download the handout. So if you're interested in doing that, go ahead and do that now. And if you're interested in asking a question, go ahead and do that now. But I'll go ahead and give you this last one I have. If the level of fluoride in my water is less than 2 milligrams per liter, that causes problems in children under 9, can my daughter still have a problem if she gets more fluoride from other sources, such as toothpaste?
Yeah, the essence of that, when you look at the data of how some of those primary and secondary drinking water standards were established, it is based on the fact that the overall average of fluoride from a drinking water system is established in some of those research data at only about 40%. So in other words, a typical person is only going to get about 40% of their approximate intake of fluoride from their water, knowing that there are other sources for fluoride, fluoride toothpaste, fluoride mouthwash, not ingested, but certainly a part of their daily lives. So I think based on the fact that you would have, a 2 milligrams per liter water source, that was all taken into consideration when the EPA developed the primary and secondary drinking water standards for fluoride, knowing that most people were going to have availability of fluoride for their body use from other sources. So all been taken into consideration. I still think that the recommended secondary drinking water standard of 2 milligrams per liter has some leeway there, even in the fact that from your diet or certainly from other uses, you're going to be ingesting some fluoride. So from my research and discussion with people in the industry, that was kind of how those standards were developed. There was consideration that there's other sources of fluoride to the normal, daily activities of a normal human being. So you bet.
All right. Well, that's it for the questions. And before I close it, I also want to tell people that this webinar has been recorded, and very soon, maybe in a day or two, should be available in recorded form. And so if you want to share that link with anyone, we encourage you to do so, and you will be able to access that recorded webinar if you go to our website, www.wellowner.org. And there's a tab, I think, on the far right at the top of the page where you can access webinars. So with that, I want to thank you, Roger, very much for your excellent presentation. I want to thank people for participating. And if you are interested in the maintenance of home water treatment systems in order to keep them efficient and effective, tune into that webinar on October 25th. With that, we want to wish everyone a good afternoon. Thank you.